This is my Newton's second law reassessment, and this is a problem. Two wooden crates with masses as shown are tied together by a horizontal cord. Another cord is tied to the first crate and is pulled with a force of 195 newtons at an angle of 20 degrees. Each crate has a coefficient of kinetic friction of 0.55. Find the tension in the rope between the crates and the magnitude of the acceleration of the system. So to start out, I drew two free body diagrams for each. I drew a free body diagram for each one of the crates, which equal two free body diagrams. And so the first mass is 14 kilograms, and this has a force being pulled on it. It has tension going this way. It has the normal force going up, and it has not going up. The normal force is going perpendicular to the surface, and then gravity is always pulling down. The summation of the forces is equal to mass times acceleration. So the summation of the forces in the y direction are n minus m1g plus f sine of theta, because sine is the y component of the force, and that is equal to 0. Solve for n. We're given mg minus f sine theta, and then f, summation of the force in the x direction, are equal to f cosine theta minus t, the tension. And so f of 1, which is the friction, the kinetic friction force, or the friction force, is u sub k times the normal force, and so we substitute n in mg minus f sine theta. F sub 1 is equal to u sub k m1g minus f sine theta, and we bring that down here, and then f net of m1 is equal to f cosine theta minus t minus f1 is equal to m1a. Now that we have that, we move on to our second mass object and look at the free body diagram. Summation of the forces is equal to mass times acceleration. Summation of the forces in the y direction are equal to m minus m2g, and that is equal to n is equal to m2g. And then the summation of the forces in the x direction are just the tension, and the frictional force for the second mass is u sub k n, and then n is m2g, so we plug that in here, and then f net of m2 is equal to t minus f2, and when we plug in this for f2, we're given t minus u sub k m2g is equal to m2a. And then when you solve for the tension, you're giving tension is equal to m2 open parentheses a plus ug close parentheses. Now this, and that's the u is the u sub k. It's the coefficient of kinetic friction. And then when you take this and plug it in here, you're given f cosine theta minus m2 a plus u sub kg minus u sub k m1g minus f sine theta is equal to m1a. And then I think the algebra is pretty clear here and how you can follow it. When you solve for, you get both the accelerations on one side, and then you solve from there, and you come out with this is what you're given. When you plug in everything that you were given in the problem, you're given accelerations equal to 4.17 meters per second or 4.2 meters per second. And then once you have the acceleration, you can come over here and find the tension. And the tension is equal to m2 open parentheses acceleration plus u sub kg. Plug in what you know, and the tension is 86.04 newtons or 86 newtons.